Welcome to class today. Today we shall be talking about how to calculate energy stored in an elastic material or energy stored in a spring. Now in previous classes we have discussed the introduction to elasticity, we have discussed Hooke's law and the basic calculations under Hooke's law. If you have not seen the video, check the description below. You will see the link to check out that video. It's important you understand that before coming to this point. Also, I have done another video on Young modulus, tensile stress, tensile strain. How do you calculate it? The link is also in the description below. Now, if you have seen those videos, you can now come with me for today's class. We'll be talking about energy stored in an elastic material. And what is the formula for calculating energy stored in an elastic material? Formula is giving us energy stored is half Fe, half Fe, where F is equals to the force or the load and E is the extension. Extension in meters, the load is in Newton. Now, if you recall, your F is Ke, that is the Hooke's law, which says that force is directly proportional to the extension. So, I can also rewrite this first equation like this. Since my F is Ke, I can also as well write my energy stored as half. I replace the Ke with this F. So I have half Ke times E. And that's going to be half Ke squared. Right? So my energy stored can also be calculated using half Ke squared, where the K is the force constant or the spring constant and E is the extension. Now let's see some example. Here is the first example. A spring of force constant 1500 Newton per meter is acted upon by a constant force of 75 newtons. Calculate the potential energy stored in the spring. Let us write out the parameters given. So a spring of force constant, so these are force constants, so our K is 1500 Newton per meter. Is acted by a constant force of this. There's a difference between force constant and constant force. They are just trying to confuse you. Constant force means the force applied or the load. So the force is 75 Newton. Then you were asked to calculate the potential energy stored. You remember the formula E is half Fe. Energy stored is half Fe. So our energy is going to be half times the force is 75 over 1 times the extension. But we do not have the extension. So because we don't have the extension, we quickly do our F equals Ke to get the extension. Alright, so our F equals Ke is going to be what? F divided by K if I make E the subject. So my F is what? 75 divided by my K is 1500. So 15 here 1, 15 here 5. So I have my extension is 5 divided by 100, which is 0.05 meters. Yes, because it's Newton per meter. So Newton in meter. So it's in meters. Now, if that is my extension, I will now use that for the energy stored. So my E is going to be half times 75 over 1 times 0.05. So if you do your calculation very well, the value of your E is going to be half times 75 times 0.05. Our answer will be 1.9 joules. So the answer is 1.9 joules. It will be 1.87, approximately 1.9. Another example. A spring of length 25 centimeters is extended to 30 centimeters by a load of 150 newtons attached to one of its ends. What is the energy stored in the spring? Take note of this. There is a difference between a length of this is extended by this and a length of this is extended to this. If I say if a length of 5 centimeters is extended by 2 meters, 5 meters extended by 2 meters, that means the new length will be 7 meters. But if I say it is extended to, that means the initial is that 5 meter, then extended to 7 meters. That is the second length, which is the new length. So to get the difference, I will do my second length or final length minus initial length to get the extension. So here, a spring of length 25 centimeters is extended to 30 centimeters. So that means the L1 is 25 centimeters, L2 is 30 centimeters. So my extension is going to be L2 minus L1, which will be 30 minus 25. That will be 5 centimeters. So that is the extension. Okay, is extended by. So a spring of length 25 centimeters is extended to 30 centimeters by a load of 150 newtons. So what caused this extension is a load which is force of 150 newtons. So what is the energy stored in the spring? So how do we calculate the energy stored? Energy stored is half Fe. So we have our force, we have our extension, because centimeters needs to be converted to meters. So you recall, how do you convert from centimeter to meter? You either divide by 100 or you multiply by 10 raised to power minus 2. So this will be divided by 100. Okay, so our extension will be 5 divided by 100, which is 0.05. 0.05 centimeters plus now meters. So our extension is 5 divided by 100, 0.05 meters. Our force is 150 newton. So our energy stored will be half Fe. That will be half times 150 multiplied by 0.05. So if you multiply, if you find the value, your answer is going to be 3.75 joules. So our extension is going to, our energy stored will be 3.75 joules. That is the answer. I want to believe you understood this. Now I'm going to give you some drill. I want you to attempt the drill and drop your answer in the comment section. This is the class drill. The energy contained in a wire when it is extended by 0.02 meters by a force of 500 newton is dash. What will be your answer? Option A, 5 joules, B, 10 joules, C, 10 raised to power 3 joules, D, 10 raised to power 4 joules. I believe you got value in today's class. If you enjoyed today's class, do well to share this video with your friends and your loved ones and your colleagues. Now, if you have not subscribed to our channel, hit the subscription button now and subscribe now. And remember to hit the notification bell so that you could be notified when we do a new content. My name is Coach Paul and this is Brilliant Tutors, where we teach you tricks to answer questions in physics, in chemistry, in mathematics, in biology. Thank you for being a part of today's class. I'll see you in the next class. Bye for now.